Hi, I'm Miss Hearn. Let's get started. In this video, we're going to evaluate a definite integral from 1 to 25 of the natural log of x, quantity raised to the 5th power, all divided by 16x, and then dx. When we're evaluating definite integrals, the first thing we want to think about is whether the integral we're given fits a common integral formula. In your textbook or online, for example here, I found Paul Dawkins' very awesome complete set of calculus notes at tutorial.math.lamar.edu, and there are other places, of course. But when I look at this list, I don't see anything that involves raising a natural log to a power. In that case, this integral that we're trying to evaluate is not going to fit any pattern, so we're going to have to make some adjustments. Now you can try algebraic simplification, but I don't see anything I can simplify here. By the way, one of the confusing things about this particular exercise is folks sometimes confuse natural log of x to the 5th, with natural log of x to the 5th in the argument. In the second case, we can bring the power out front, but we cannot do that in this case. So this is equal to that, but we have something entirely different. So instead, I'm going to consider a u substitution. Now, when you start to think about u substitutions, there are 5 very common u substitutions. Remember, u substitution is used to rewrite integrals to match the common integral formulas. And it in fact often reverses the chain rule. There is no chain rule for integration like there is for derivatives, but instead what we do is we let u equal the inner function and use a substitution. When you're deciding on u, here are some of the possible u substitutions. If you have a quantity raised to a power, then you can let u be that quantity. So in the first example, I have 2x plus 3 to the 100th. We could let u be the 2x plus 3. Or you can let u be the denominator of a function in the integrand. For example, here I have 1 over 2x plus 3. You could let, again, u equal 2x plus 3. You could also let u be the argument of a trig function, whether it be sine, cosine, tangent, whatever's inside the argument, like this 2x plus 3. Sometimes if you let u equal that, you can get a nice u substitution. You can let u be the exponent of an exponential expression, like e to the 2x plus 3, let u be the 2x plus 3. Or the last thing is any transcendental functions. So transcendental functions are like trig functions, natural log functions, functions like x to the x power, basically all the weird functions that cannot be written as a combination of addition, subtraction, multiplication, division, and exponentiation. In that case, we are going to try letting u be one of those functions. For example, in the integral of 1 over x natural log of x, we would try letting u be the natural log of x. Or in the case of sine of x plus 1 times cosine of x, either let u be sine of x plus 1 or u be cosine of x. Okay, so out of all of these options, the problem that we're working, the only ones that I see are possibly to let u equal the denominator, or we could let u equal natural log of x, which is both a transcendental function and the quantity being raised to a power. I don't think u equals 16x is going to be real helpful here, because du would be 16 dx, and that would not give me any way to substitute u's in for natural log of x to the 5th, and it's not going to simplify my expression. So instead, I'm going to try the other. And don't be afraid to try multiple u substitutions until you find something that works. I'm going to try letting u be natural log of x, so that means that du would have to be 1 over x dx. And the way I like to think about it is I look at my original integral and I try rewriting it where I separate out these quantities, the u and the du. So I have the integral from 1 to 25, and I'm going to separate out the integrand into a product of natural log of x to the 5th times 1 over 16 times 1 over x. And the reason I'm doing that is because I want to be able to see that 1 over x and the dx. which I see right here, that's going to be my du. And this guy inside the parentheses, that's going to be u. And the only thing I have an extra 1/16. That's okay. We can always just bring that coefficient out front of the integral. The only other thing I need to worry about is, remember that since this is a dx integral, these are x values. In fact, I like to remind myself these are x values by writing x right here. If I'm going to change this to all u's, it doesn't make sense to have bounds that are x's. So let's figure out when x is equal to 1, what would u be equal to? It would be the natural log of 1, which is going to be 0. And when x is equal to 25, u would be equal to the natural log of 25. So let's make our substitution. We have the integral from u equals 0 when x equals 1 to u equals natural log of 25 when x equals 25 of u to the 5th du, and I'm going to bring that 1/16 out front. Now this fits one of my common integration formulas, right? This is the situation x to the n. So we can use the rule that we can add 1 to the exponent and divide by it. So this is going to be 1/16 times u to the 6th over 6, and we're going to evaluate that from 0 to natural log of 25. Okay, so this is going to be multiplying 1/16 times u to the 6th over 6. We're going to get a denominator of 72. So we have u to the 6th over 72 evaluated from 0 to the natural log of 25. Now that's going to be the natural log of 25 to the 6th power over 72 minus 0 to the 6th power over 72, which of course is just going to be 0, so that's going to go away. Okay, now here's one of the confusing things about this problem. It can be tricky, particularly in systems like my labs, which my students are using, writing the answer in a way that the system accepts. It might accept natural log of 25 to the 6th over 72, but it might want you to simplify a little bit more. And you might be wondering, how on earth can I simplify that more? Well, remember, the natural log of 25 is the same as the natural log of 5 squared, which by the power rule of logarithms is 2 times the natural log of 5. So we could think of this as 2 times the natural log of 5 to the 6th power over 72. When you multiply inside of an exponent like that, you can just raise each factor to the power. So 2 to the 6th is 64 times the natural log of 5 to the 6th over 72, and that fraction can be reduced. This would be the same as 8 natural log of 5 to the 6th over 9, and so this would probably be considered the most simplified form. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video. You can also leave comments and questions below, and you can click on the links to my other videos or subscribe to Miss Hearn Mathematics.